Hello and welcome to this video on carbonates. Today we will focus especially on calcium carbonate and calcium oxide. Limestone consists of mostly calcium carbonate, CaCO3. Lime, which is calcium oxide, is manufactured by the thermal decomposition of calcium carbonate. Here is the equation for the reaction. Calcium carbonate breaks down to calcium oxide and carbon dioxide. Slaked lime, calcium hydroxide, is made by adding a small amount of water to calcium oxide. Here is the equation for this reaction. Calcium oxide and water react to form calcium hydroxide or slaked lime. Lime water is a solution of calcium hydroxide in water. Because it has a high concentration of hydroxide ions, the solution is alkaline. The addition of carbon dioxide to calcium hydroxide produces the material that we started with, calcium carbonate. Here is the equation for that reaction. Have you seen this reaction before? Carbon dioxide, lime water. Can you suggest an observation that you might note down? Yes is the gas test for carbon dioxide. The lime water turns milky when in the presence of CO2 due to the formation of the insoluble precipitate white calcium carbonate. The combination of these three reactions constitutes the limestone cycle. Now we move on to the uses of limestone and limestone products. Limestone is used in the manufacturing process of iron. In the production of iron, limestone is added to the blast furnace, where it decomposes to form lime, calcium oxide, and carbon dioxide. The lime reacts with silica impurities as shown in this equation. It forms calcium silicate, which floats to the top of the molten iron and is tapped off. Limestone is also used in the manufacturing process of cement. Cement is manufactured by heating a mixture of powdered limestone and clay in a rotary kiln, or cement mixer. Once heated, calcium sulfate and water are added, which produces cement. What is cement, I hear you ask? Cement is a hardened, interlocked structure of calcium aluminate and calcium silicate, which we saw earlier in the blast furnace. Soil pH is analysed to indicate the acidity or alkalinity of soil. Most plants favour a pH value of between 5.5 and 8. Changes in soil which cause a pH to be outside of this range adversely affect plant processes, resulting in reduced growth and crop yield. Soils become acidic from acid rain, the overuse of fertilisers which contain ammonium salts, and by the excessive breakdown of organic matter by bacteria. Calcium carbonate is preferred to lime to neutralise the excess acidity in the soil because it does not make the water in the soil alkaline. Lime is used in lime mortar and in flue gas desulfurization. Flue gas desulfurization involves spraying acidic sulfur dioxide emissions with jets of slaked lime to reduce pollution by neutralising these gases before they leave the factory chimneys. Lime can also be used to treat excess acidity in soils. However, it dissolves in water, so the addition of lime must be monitored carefully, as if it is added in excess, further damage could be done.